This video is about the topic of iterations. Now, iterations is a topic that is really special when you cover it in MATLAB. It's a topic that exists in when you talk about all computer languages, but MATLAB is especially interesting when it comes to iterations because there's a bit of magic going on in MATLAB in terms of when you deal with vectors. There's some MATLAB magic going on in terms of iterations. A lot of stuff that we do when we do 2 times some vector 1, 5, 7, MATLAB just automatically does, the multiplication. So it's 2, 10, 14. Well, in a lot of languages you don't have that, and so MATLAB's sort of pulling this out of its magic hat, and you have to do things called iterations, which means a lot of things that we're going to cover in the section on iterations, you don't necessarily have to do it this way in MATLAB. But it is worthwhile understanding iterations when you talk about this in the context of learning programming languages, and there are also times in which you would want to use iterations in MATLAB. So MATLAB's built-in functions don't totally keep you from having to use iterations. So it's a topic that's very, very important and that is very needed. And we'll go back and forth and look at how MATLAB's built-in functions do things with iterations, and how you have to do some things outside of those built-in functions. So the iterations comes in two flavors, 2 parts. When you talk about MATLAB, there is the for command. Iterations are also referred to as loops, and you'll see why when we do the flowchart diagram. There's the for command, and there is the while command. So we call these for loops and we call these while loops. So you get for loops and while loops. We're going to focus now on iteration in general, but we're going to focus specifically on for loops in this video, and then in subsequent videos we'll talk about the while loops. So let's look at the for loops and introduce the concept of iterations with the for loops. So now, once again, just out with the if statement, the if statement allows us to interrupt program flow, the if and the switch. So you come down, you're doing something, and then you make a decision, and your program flows this way if something's true, and it flows this way if something's false. And then you can do another block of code here, and a block of code here, and you come back, and then your program continues to run with blocks of code here. So this is how the if or the switch in the conditionals work. Well, iterations allow you to change program flow in the sense that it allows you to re-execute lines of code. So the general diagram, we'll get to this more specific diagram in a minute, but the general diagram is you come in to your iteration and you test for something, and if it's true, you execute some block of code, and then you go back, test again, and keep doing that. So that's the true side. That's if this thing keeps going. If you're done or false, and it changes a bit with between the while loop and the for loop, then you're done with this iteration, and then you continue on with blocks of code. So if this is code block 1, and this is code block 2, and this is code block 3, then the sort of equivalent, not exact, but sort of equivalent flow diagram over here with a loop is you would do some code block here, some code block here, and then you would come here, set up your iteration here, whether it be a for or a while, and then you would go through that iteration until your condition is either false, or in case of the for loop, you're done. And when you're done, then you just continue on flow with the rest of your program. So this whole thing about doing things over and over again, this is the concept, and this is why they call them looping. This is why they call them loops. So this is the loop over and over, and then when you're done with the loop, then you come out of the loop, and then you continue on with your code blocks, and your program continues to flow. So this is how iterations alter the flow of the program, as opposed to the way conditionals over here alters the flow of the program. So let's now look a little bit deeper at the flow diagram for the for statement. Once again, I'll do what I just did before. You have some code block here, and maybe it's some code block here. So you're coming along, executing your program code sequentially, and then you hit a for statement. And the way the for statement is set up is your for some variable, which I'll say var, V-A-R, some variable equals some vector. Some variable equals some vector. Okay? And so, and then while that variable goes down that vector, and I'll explain a little bit more in a second, you execute this code block. When you finish executing that code block, you go back up here to the for loop, and if you're not done, you continue to go through here. Okay? Once you're done, and I'll explain what that means in a second, once you're done, then you exit the loop, what we call exit the loop, and continue executing whatever blocks of code that you're going to do after the loop. Okay? Now, a little bit more detail here. Let me write this a little bit better. This is a variable var. So let's just say we had some variable x, and it was equal to some vector. Let's go for 34, 18, and I don't know, 27. Okay, so your variable is equal, your variable x is equal to some vector 34, 18, and 27. Okay, so now when you come down, you're executing this code block, you execute this code block, you hit the for loop. You hit the for loop, x is going to equal the first value in that vector, which in this case, or your variable is going to equal the first value in that vector. In this case, variable x is going to equal the number 34. So when you get over here and you start executing the inner part of the for loop, x is going to be equal to 34 the first time through the for loop. Then when you get back and you finish executing whatever code you have within your for loop, you're going to come back up. Now x is going to equal the next value in the vector, which in this case is 18. So the second time through, x is going to equal 18. You're going to come through, execute this code block, come back up, then x is now going to equal the third value in this vector. In this case, it's 27. So x is now going to equal 27. You're going to go through, do this code block, come back up. Now, the vectors that you've reached the end of the vector, so x has nothing more it can equal to, so now you are done. And once you're done, you come down and now you go to the next code block in your script or your function. So your for loop is done and it's now exited, and you come out and you now execute these code blocks. So that is how a for loop works. Okay, that is the basic form of a for loop. Once again, you're executing code block. You're coming through your function or your script, you're executing your code sequentially, you get to a for loop. It is for some variable equals some vector. In this case, in this example, variable x equals the vector 34, 18, 27. So now, when you hit it the first time, x is equal to the first value in this vector. So come through, x is equal to 34. You execute the code block that's inside the for loop. You go back up. Now x equals the next value in the vector. In this case, that value is 18. So now x equals 18. You come through, you execute the code block inside the for loop, you go back up. Now x equals the next value in the vector, which is 27. So now x equals 27. You go through, you execute this code inside the for loop, you come back up, you've reached the end of your vector, x is equaled everything in the vector, your variable is equaled everything that's in the vector, so now you are done, and then now you exit out of the for loop and continue on executing your code blocks in sequence. So that is the general basic way that a for loop works. Next up, we're going to look at some examples that I'm going to do here on the board, and then I'm going to do those same examples in MATLAB.